through what's new about this body.
You know, we've redesigned many of the components to make it more reliable, to make the skins work better, and to protect it if it does fall. This robot has, and I'm going to go out there and point at a few things. This has cameras. It has 2 sets on the front, and 1 on each side and 1 on the back, so it can see in all directions.
I gotta say too, it looks a little more banged up, I think, than I've seen a lot of your robots. It looks like it's kind of been through the ringer.
We've been testing these things relentlessly. As I say, they usually go through many hours of testing a week. They do fall still. This is also designed, these are like roof racks, so that when you build your special platform, like maybe the previous speakers will make a deck that you can take a drone off from, and they'll just attach that. There's connections for an Ethernet so that they can communicate, and then we have our API. This also has a special radio on it. It has built-in Wi-Fi, but for an event like this where you all have your phones out and you're texting and stuff, Wi-Fi can be unreliable, so we're using a spread spectrum radio, and of course it's got the arm. Why don't we show off the arm? One of the great things about a mobile robot like this with an arm is that the workspace is essentially infinite, and the motion of the base contributes to the motion of the arm. If you have a fixed arm, they're usually very limited to what they can do. And of course, we've coordinated the arm with the body, so Lily is actually just driving the hand. I know you think it's a head, but it's really a hand. And she can drive it fore and aft and sideways, and now she's put it into a mode where the hand is stabilized in space. I love to call this chicken head mode. And really, people have the capability of stabilizing their manipulators and their heads while the rest of it moves. And it really facilitates the ability to handle objects and work in the world as the robot travels around the world.
Can you talk a little bit about the control mechanism?
So this has onboard computers that are interpreting the data from the vision. They also interpret data from the load cells in the link, so it can feel the environment. It's balancing itself. I won't kick it. We're not allowed to do that anymore. But I'll show you. If I push on it, if I push hard enough, it'll step. And it's pretty robust. If it does fall over, it can get back up. So there's the low-level stabilization of the robot. And then it has vision that it can use to negotiate obstacles, like this block. And here, Lily, I want you to run me down with the robot. You won't do it, huh? I wouldn't promise that it's never going to run into anybody, but it's using its vision to treat me as an obstacle, and then even though Lily's just saying go straight ahead, it goes around. And later on, I think after the show closes, we're going to demo this out front. You can drive it and see, you can see if you can run one of us down with it if you want. And then on top of that, we have navigation software that can autonomously navigate around space. And eventually, you guys will all be writing apps that run and interact with the controls on the robot.
So what